All right, hey guys, so today we are doing the trig functions. All right, we are going to do all 6 of them today. We're going to start with the first 3 that you should probably be familiar with from geometry, and then we're going to build into the other 6, and then we're going to loop back to our unit circle that we started last class and talk about how these ratios can be applied to that unit circle. So we're coming full circle. Yeah. All right. So here we go. We are going to do some math together. Okay. Let's go. All right. So here are your guided notes that you should have been provided with from the sub. All right. So we are just going to go through these together, fill them in, talk about stuff, and that will be your day today. So then hopefully after this, you will be able to fully complete your classwork assignments. All right. So first off, we're going to do our 3 basic trig functions. All right, so most of you should know SOHCAHTOA. All right, that's generally how it's taught in geometry classes, and this stands for sine, which is opposite and hypotenuse, cosine, which is adjacent, hypotenuse, and then tangent, which is opposite and adjacent. All right, so down here I'm going to start making them into ratios. So the sine of theta, 2 to 2. So we have our little reference triangle that I'm drawing here. So we know this is x, this is y, this is our radius of our circle, and here is theta, right? So sine of theta is the opposite leg over the hypotenuse. All right, so if we are using our reference triangle here, so theta is our angle, so opposite theta is going to be y, and then our hypotenuse is our radius. All right, so our sine theta of our coordinate plane reference triangle is going to be our y value divided by our hypotenuse or our radius value. All right, cosine of theta, which is adjacent over hypotenuse. All right, so adjacent means next to or touching. So in this case, theta, our angle, is next to or touching leg x. So x is our adjacent side, and then our hypotenuse is r. Now, people ask me all the time, can r be adjacent to our angle? And the answer is yes, r is adjacent, but when we're talking about adjacent, we're talking about legs of our right triangle, and the hypotenuse is not a leg. And besides, hypotenuse can't be adjacent because it has to be the hypotenuse. All right, so adjacent means the not hypotenuse side that is touching our angle. So in this case, it's going to be our x value. All right, last but not least is tangent theta, all right, which is opposite over adjacent. All right, again, if we look at our reference triangle, opposite theta is going to be y, and adjacent to theta is going to be x. Right? These are really important ratios that are going to stay with us, right? Because again, we are graphing a lot on our coordinate grid, so understanding that essentially sine is going to go with our, oops, didn't mean to cross that out, I thought it was the highlighter. Sine is going to go with our y coordinate, and cosine pretty much goes with our x coordinate. All right, and then tangent is going to be the ratio of y over x. All right, so this is a big, important piece here, all right, especially as we start moving into our unit circle. So what we're going to do first is really just make sure you know how to use sine, cosine, and tangent, do a couple practice ones, and then we'll introduce the other 3 trig ratios. All right, so the first problem, number 1, is saying that sine of 35 degrees equals x over 5. And this is important, right? When we're doing trig and it's just straightforward trig, it's always going to be your trig ratio, whatever trig ratio, trig function you have, of some angle equals some fraction. All right, so it's going to be some fraction using the side lengths, right? So it's either adjacent or in a hypotenuse, opposite, adjacent, whatever, right? So your fraction is always going to be like your ratio of your side lengths, right? So it's your trig piece, then it's your angle inside, and it's going to equal that fraction or ratio of the side lengths of your triangle. All right, so for this one, we have sine, our angle is 35 degrees, and it equals x over 5. So I'm going to start by sketching a triangle here. Ooh, that's a terrible right angle, but we'll just pretend. There's my theta, and it says sine is x over 5. And remember, and we know that theta is 35, so I can just put 35 instead of theta. Right, so sine is opposite over hypotenuse. So opposite is x, hypotenuse is 5. All right, so that's the setup of our triangle using the information given. It then says to find the missing sides and angles. So it wants us to find all missing sides and all missing angles. Well, the angles are easy. All right, this is a right triangle. Hopefully you remember the rule from geometry. All three angles of any triangle have to add up to 180 degrees. One of my angles is 90, so then my remaining two angles must add up to 90. So my missing angle is going to be 90 subtract 35. And what is that? 55. So my remaining angle must then be 55 degrees. So now all I have left to do is find my two missing leg lengths for my triangle. I'm going to find one by solving the equation that they already gave us. All right, so if I multiply both sides by 5, I get 5 times the sine of 35 degrees equals x. And I'm going to plug that into my calculator, which I'm going to pause the video and go get because I forgot I needed it. Okay, I think it was paused. I honestly have no idea. I hope it's recording now. If not, I'm about to waste my time, and then I'll figure it out once I'm done recording because it doesn't tell me. There's nothing on here that tells me. Anyways, it's fine. I think we're recording. All right, so here we go. Syntax error. Perfect. My kid was playing with my calculator. All right, so we are going to go type in 5 times the sine of 35, enter. And you want to make sure that your calculator is in degree mode. To do a quick check on that, you're going to go to mode. Now I know your calculator looks different than mine, obviously, probably anyways, but mode is up at the top. And there is degree versus radian. If you're on the TIs, it's going to be the third line down. You want to make sure that degree is highlighted. I am in the right mode, so I ended up with an x value of 2.87. I would say it's pretty safe to round to 2 decimal places for finding side lengths, so that's what I did. Right, two decimal places is pretty safe, unless otherwise specified. All right, so I have my one side length. Now I have two options here. I can either A, use trig to find my other side length, which is a completely fine option, or because we now have two sides and it's a right triangle, I can use Pythagorean theorem. And I'm going to go through and do Pythagorean theorem because I like it better. So 5 squared minus 2.87 squared equals my missing side. I'm going to call the missing side, I don't know, y, sure, y squared. So in my calculator, 5 squared minus second answer squared, enter, and square root of that gross number is going to give me 4.1. And there's my last side. So there we go. And that doesn't seem right. So I'm going to double check my math because 4.1 seems too big. Nope, it's right. I double checked. All right, so it is good. I did it doing I did it using trig just to make sure, and it is right. It just seemed really close to 5, so it threw me off, but it is perfectly fine. Okay, so that is done. We have now found all 3 side lengths and we have all 3 angles, so we have solved the triangle. All right, moving on to number 2. So this is tangent of theta equals 5/9. So first we're going to start by sketching our triangle. So here we go, boop, boop, boop. All right, so I'm going to put theta down here. Tangent is opposite over adjacent. So opposite, my angle is 5, adjacent is 9. All right, now I'm going to start by solving for theta because my problem is already set up for me. You could find your missing side first. Either way is fine. We're going to eventually do everything. I'm just going to go ahead and find the angle first. Now, this one is using inverse trigonometry, which you did do stuff like this in geometry. It does require you to use a different button on your calculator. So when we type this in, right, so essentially if we have tangent of theta equals 5/9. We want to isolate the variable. Theta in this instance is our variable, so the only way to move tangent to the other side is to do the opposite of tangent, which is inverse tangent. So if I do inverse tangent of both sides, the inverse and tangent cancel each other out, right, because they're inverses of each other, and we're left with just theta equaling inverse tangent of 5/9. All right, so everything I do in my calculator is going to be just about the same, except I'm going to hit the second button when I go to hit my thing. So I'm now going to do second and tangent, and then 5 divided by 9, enter, and this is going to give me theta as 29 degrees. Now, it's generally standard practice to round angles to the nearest degree, whereas we round side lengths to either 1 or 2 decimal places, unless otherwise specified. All right, so I am rounding it to 29 degrees. So if theta then is 29, I can find my missing angle by subtracting from 90, and I get 61 degrees. All right, so I found my 2 angles. Now all I need to do is find my hypotenuse of my triangle. So I'm going to go ahead and use Pythagorean theorem. 9 squared plus 5 squared equals hypotenuse squared. That's going to, so 9 squared, 5 squared, 106. Square root both sides. So I have the square root of 106, and let's see if I can simplify that any further. I cannot. So that is as simplified as it goes. Awesome. All right, so that is setting up the triangles and applying the ratios. Now we're going to jump to our coordinate plane. All right, so it's kind of mixing those reference triangles in with now sine, cosine, and tangent because we now can set those up. All right, so first what we're going to do is find out the coordinates of this point right here. So this coordinate point is -6, 2. Go ahead, draw down and over. I now have my reference triangle. All right, I know that my x-axis is -6 and my y-axis is 2. So I can go ahead and start filling in some pieces here. This is going to be -6, this is +2. My hypotenuse would be 2 squared plus -6 squared is my hypotenuse squared. So 4 plus 36, so is that 40? So I square root, so that's going to simplify to 2 root 10, right? So 40 would be 4 times 10. 4 simplifies to 2. That is my hypotenuse. So 2 root 10. 2 square root 10. All right, so now we're going to go ahead and find our sine, cosine, and our tangent value. All right, so sine, so we're using the reference angle. All right, so we're using a reference angle of our triangle to go ahead and set up those ratios. So sine would be 2 over, I'm going to do it over here so I can simplify. So sine is opposite, so 2 over hypotenuse, 2 root 10. The 2's are going to go ahead and simplify out, and then I'm also going to need to rationalize my denominator, giving me square root of 10 over 10 for my sine value. All right, cosine is what, negative 6 over 2 root 10. All right, simplifying, I get negative 3 over 1, and then rationalizing, we end up with negative 3 root 10 over 10. Negative 3 square root 10 over 10. All right, tangent, this one's going to be nice. All right, so opposite is 2 over adjacent negative 6, so that simplifies to negative 1/3. Okay, now that is all this question asks you to do, but I want you to start thinking about figuring out the angle that is actually theta. So we use the reference angle of our triangle to go ahead and set up our ratios. We can use trig to then find that reference angle. All right, so just like we did with the problem above when we were solving for theta, we're going to go ahead and do that again. Now, I always recommend using tangent because tangent generally is going to be the one that has the whole number points instead of using the square roots in them, but you could do any of them, it doesn't matter. So I'm going to go ahead and solve this. All right, so remember, when we're setting this up, this theta that we're going to find is the reference angle for the rotation. All right, so I'm doing inverse tangent. And you don't really need the negative with the 1/3. I'm just going to actually put in the positive because I'm just getting the reference angle here. So I don't really care to put in the negative because it sometimes can give you weird stuff, especially if you do it with cosine. So I'm just going to go second tangent 1/3. And this gives me 18 degrees. So remember, I'm rounding to the nearest whole number. I got 18.4, so I rounded down to 18. All right, so what that is telling me is that this reference angle right here is 18 degrees. Now, our actual angle, right, remember we're rotating from the positive x-axis to that terminal side. So remember that green line that you're seeing in the picture is the terminal side of our angle. All right, so our actual rotation is going to be, for this one, 180 subtract 18 to give us our actual rotation angle. So minus 18, so 162. Now I know it did not ask for that in this problem, but that's just something to start thinking about. So when we're setting up these ratios, yes, we're setting them up for the reference angle of that triangle that we created. It is actually accurate. It is going to actually be the correct values for the full rotation angle. We're just using the reference one to set it up. So that 18 degrees is not actually the angle that we're making. Our rotation started from the positive x-axis. Okay, moving on to the back of these notes. So now we're going to look at the reciprocal trig functions. All right, that is what they are officially called because reciprocal means you are flipping upside down, and that's what we're going to be doing. So all sine, cosine, and tangent have their own reciprocal, and they each have their own names. So when we're doing reciprocal, right, that means we're flipping. So if we were to do 1 over sine, which would then be hypotenuse over opposite, this is the trig function cosecant, abbreviated CSC. All right, so yes, I know it's stupid. Why is sine's reciprocal cosecant? I didn't get to pick the name. I think it's dumb. This one seems like it should be with cosine, but it's not. So there you have it. Anyway, so if you were to flip sine upside down, it is the function cosecant, which is then the ratio of the hypotenuse over the opposite side. All right, cosine, you're going to really love this one. All right, if we flip cosine upside down, right, that's what reciprocal means, flip upside down. All right, that means we would be doing the hypotenuse side divided by the adjacent side. This is the trig function secant. Doesn't that just make so much sense? And it is abbreviated SEC, then your angle, secant. All right, last but not least, and this one actually does make sense. So kudos to the mathematicians that came up with this one. So if we were to do 1 over tangent, then it flips our ratio. So now it's adjacent over opposite. This is the trig function cotangent. I told you it made sense. Abbreviated COT, and then theta is our angle. So those are the remaining 3 trig functions. So now there are a total of 6. We have sine, cosine, tangent, cosecant, secant, and cotangent. All right, so we are now going to use this little triangle right here to practice setting up, come on, cursor, there it is, to setting up this these ratios on this triangle. So first thing we're going to do here is to find the length of our hypotenuse. So 5 squared plus 4 squared equals h squared. 25 plus, I'm not trying to do math right now, so I know that's probably easy math, but I wasn't really feeling it. And it's pretty positive 41's prime. So this is just root 41 for our hypotenuse. Cool. Okay, so setting up our ratio. So we're going to start with just sine. So sine for this one would be, so let's put theta down here. Didn't really label it. All right, so we get to pick. So I'm picking to put theta down at the bottom. All right, so theta's down there. So my sine of theta would be 5 over root 41, which we are going to rationalize and rewrite as 541 over 41. All right, then we have our cosine of theta, which would be 4 root 41. Rationalize that, so 4 root 41 over 41. And then we have tangent, which is nice, and it's just 5 over 4. Awesome. Now, I know my head is running into... don't do whatever I just did. Okay, just give me my head. There we go. Now I can float in the bottom of the screen. Okay, so now we're going to do the reciprocal functions. So cosecant, all right, is going to be hypotenuse, root 41, over opposite, which is 5. Now what's nice about this is that we don't have to rationalize because the square root is already in the numerator, and that's one of the benefits of having these reciprocal functions. So sometimes it can get really nasty if you have this, gross hypotenuse, and it's easier, prettier to put the square root on the top without having to rationalize. You can then just use a reciprocal function instead of the basic trig function. All right, so that's one of the benefits. It gives you some more choice when you are doing your calculations and solving. All right, so then secant actually has the same kind of feature. So hypotenuse, root 41 over adjacent, which is 4. And then cotangent is just flipped tangent, so 4 over 5. Those are your 6 trig functions. All right, I'm going to move my head back. Come back, page. I don't even know what I'm moving right now. There's just too many buttons. I don't even know what I did. All right, it doesn't matter. Okay, so with our unit circle, all right, so remember, a unit circle is just a circle with a radius of 1. All right, so here's just the normal setup, right? So in our unit circle with a radius of 1, if I were to then do my trig function, so sine theta, right? We know that sine is opposite over hypotenuse. What's nice now is that since your hypotenuse is 1, because your radius is 1, in the unit circle, your sine value is just y. Sine is the y value of your coordinate, right? Which is really helpful. You don't have to make an awkward ratio, you just already have it. The same thing is true with cosine, right? So if we do cosine, that's adjacent over hypotenuse. So x over 1, which is just x. So in our unit circle, our cosine value for any angle is just the x coordinate. All right, tangent is opposite over hypotenuse. Now this one doesn't really change. This is opposite over hypotenuse. Pfft, opposite over adjacent. All right, which is just going to be your y over your x. And that's not really affected because it's a unit circle, right? There's no hypotenuse in there. But it is still an interesting and important ratio to remember. Now, bringing in those reciprocal functions. So cosecant, let's do this in the same color so we're matching. So cosecant, since it is 1 over your sine value, it's just going to be 1 over the y value. So you're just going to flip your y value upside down. Same thing is true for secant. It's going to be 1 over x. And last but not least, your tangent value, all right, or cotangent, is just going to be x over y. All right, so these are how all of your trig functions work on our unit circle. So now we're going to go ahead and last but not least, we're going to fill in this trig unit circle value chart situation that we have here. So hopefully you have filled in your unit circle, and now we're just going to kind of figure out these trig values using what we have from our unit circle. So here we go. I lost the mouse again. Okay, cool. Sorry, I lost the mouse. All right, so filling this in, I'm gonna go through this really quickly. I'm sure some of you are gonna want to pause this because this is gonna be kind of fast. All right, so degrees for 150. All right, so that means that my reference angle is 30 degrees. 150 to 180 is 30. My 30-degree angles are my angles that are over 6. So I know that this is some pi over 6. I am in the second quadrant because that's where 150 goes. So that must mean that this is 5 pi over 6. All right, so thinking about fractions, I know that 180 would be 6 over 6. So this is going to be a little bit less than that. So 5 pi over 6. All right, now my coordinate for 5 pi over 6 has a negative x value, so it's negative root 3 over 2, positive 1/2. All right, so sine is then my y value, 1/2. Cosine is my x value. Tangent is y over x. Now, yeah, I know this is pretty gross to simplify, but once you get pretty fast at it, then you'll learn the pattern. All right, so it simplifies to negative root 3 over 3. Cosecant is going to be positive 2. Secant is going to be negative 2 root 3 over 3, right? I'm just flipping the fraction and then rationalizing to move the square root of 3 to the top. And then cotangent, which is negative root 3 over 2 divided by 1/2. The 2's just cancel, leaving with just root 3. Like I said, I know I went through that fast, but you should be getting fast like that as well. All right, next up I have, all they gave me was a sine value of root 2 over 2. So I know that I'm at some type of 45-degree angle. So I know that it's something pi over 4. They then told me that my tangent is negative 1. All right, so sine is positive, tangent is negative. These two things can only happen in quadrant 2. So I know I'm in quadrant 2, which means that this pi over 4 is 3 pi over 4. My degree is 135. And my cosine is negative root 2 over 2, right? So my coordinate is negative x, positive y. All right, so tangent is negative 1. Cotangent is also going to be negative 1, right? We flip negative 1 upside down, and it's just negative 1. All right, cosecant, so if I flip square root of 2 over 2, it's just the square root of 2, because it ends up simplifying. And then secant is going to be negative square root of 2. All right, last but not least, all right, I'm given secant is positive 2, cotangent is negative. So if secant is positive and cotangent is negative, that means I have to be in quadrant 4. All right, so I am in Q4 for this one. All right, now I have a secant value of 2. All right, well, I know that at my pi over 6 or 30-degree angles, my cosecant is 2, which means this can't be 30 degrees. The only other option is that it has to be my 60-degree angles. So in quadrant 4, my 60-degree angle would be 300 degrees, and it's going to be 5 pi over 3. All right, so in quadrant 4, everything is 1 less than 2 full if you're thinking about fractions. So 2 full thirds would be 6 thirds, so 1 less than that would be 5 thirds. All right, remember you're thinking of your circle like fractions, not trying to really memorize it, you're just trying to think of them as fractions. All right, so that means that my sine value is going to be negative root 3 over 2, and my cosine value is positive 1/2. My tangent value is going to be negative root 3, and my cosecant is going to be negative 2 root 3 over 3. All right, that is it for this video. I know it went pretty long because we did cover a lot of content. I tried to go pretty quickly. Feel free to watch this again or whatever if I went too fast in some areas, or maybe you listened to it at a faster speed. Hopefully that worked out for you, right? Because some of this you should have already known, so maybe you didn't really need to watch the whole thing word for word. All right, anyways, I hope it was informative, and if you have questions, write them down and we can go over them when I come back from Thanksgiving break. All right, bye you guys, see you next time.